We are Team Green and we have taken the project course EQ2440 Project in Wireless Communications. Our objective was to design an Android application for transmitting files over an acoustic channel. What this means is that the file is being transmitted by the loudspeaker of one phone and received by the microphone of another. The application is also designed to be able to transfer files through a 3.5mm sound cable between the phones. But before doing a demonstration, let's check out how the system works. Every file is a sequence of zeros and ones. The transmitting phone is loading that sequence, but before it can be sent, the data has to be prepared by a process called modulation. There are many types of modulations available, but in this project we chose to implement pulse position modulation. In pulse position modulation, the bits of the file are being transmitted as a long train of pulses, and the time in between the transmission of each pulse decides what bits were being sent. 00 is transformed into 1000, 01 is transformed into 0100, 11 is transformed into 0010, and 10 is transformed into 0001. This creates a long sequence of ppm symbols, carrying the file information. But because the loudspeaker cannot simply play zeros and ones, the ppm symbols are being shaped into a train of pulses. Varying the shape of the pulses will change the data rate and sound of the signal. To help the receiver find out when the transmission of the file begins, every transmission starts with a special training sequence which is already known to the receiver. In ppm, it is very important to keep track of the pulse train. As an additional safety measure, several smaller training sequences are used in between to divide the file into several packages, which helps keep the receiver synchronized during the whole transmission. By calculating the cross-correlation of the received signal and the training sequence, the receiver can detect in between what points the transmission of each package took place. Upon examination, the received data looks very different from the transmitted. This happens for two reasons. 1. There is some background noise that is being registered by the microphone. And 2. The channel, or the room that we are in, creates echoes of the already sent symbols, which interfere with the ones that are currently being transmitted. This is known as inter-symbol interference. However, this problem can be dealt with. Because of the training sequence, the receiver knows what the received data is supposed to look like. The receiver can compare the received data to the training sequence to estimate the channel and how it affected the data during the transmission. It then tries to mitigate the echoes created by the channel by convolving the received signal with a zero-forcing equalizer calculated from the channel estimation. This makes the received data easier to process. And here we have a working demonstration of the application in action. We first open the application on the two phones and select the modulation of our choice, where we can choose from 2, 4 or even 8 ppm. We then set one phone as a transmitter and the other as receiver. After that, we load a file of our choice from the phone's memory and the transmission is ready to begin. We can see how rapidly it is progressing. And there, bang! The transmission is finished and a beautiful picture of a green apple has been successfully transferred with no errors.